So as scheduled, we will have part 1 tomorrow, which is 4, 5, or 6 problems. Then part 2 will be 4 or 5 problems. There's no pattern to these. They're either mole to mole, mole to mass, mass to mole, mass to mass, limiting reactant, or percent yield. They all interconnect with one another. So with that being said, would you just like me to throw a random problem up on the board?
I think we need to refresh on like mole to mass and those things.
We did that yesterday.
I thought
Oh, it was so much fun you want to do it again.
I thought we just did percentage yields yesterday.
Well, that still includes mole to mass, mass to moles, because those are in those steps. Did you write those down?
Nah.
No? Why not?
Because I got them from when we used to do them.
Oh, so you do know how to do these then?
Yeah.
Oh, well then you just need a refresher.
Sure.
Okay? I mean, yes, we are here to help you, but sometimes are we here to help ourselves or not? Yes? No?
Yeah.
I don't know. So if we are here to help ourselves, what would probably be the best thing to do then?
Get your notebook out.
Right. I agree. I mean, and if you don't, I mean, that's entirely up to yourself. But it can, I'm not saying it is, may I make it sound like it is, but and to me, I think this is a good analogy. I was talking to the seniors about this as I was grading some of these papers last night, because I've fallen behind. But how many times in a row do you think you ladies forced a 10-second call? I said 3, but I think it was 4. Okay? So what do you suppose the best way you did that? You forced the opponent handing the ball into the corner. They did it once. Then they did it again. Then they did it 3 times. So obviously they didn't learn and they kept doing it over and over again. So if you choose not to write these down and you keep making the same mistakes, how can we help you bridge that gap then if you're not helping yourself? That's what maybe could be frustrating on our end. All right. So let's say when okay, so if we have some acetylene, okay. Okay.
It would help if you like actually made you guys practice. Maybe like do 2 different acts. Just let them jog the whole time.
Okay. So this is what I would expect you to know. How many of you could write this equation out? I don't expect you to know what acetylene is, but I do expect you to know what oxygen, water, and carbon dioxide are, and where they go in the reaction. Okay? So if C2H2 is reacting with oxygen, what does that tell you then? They're on the left side. Okay? Okay. So this is obviously a hydrocarbon, and it's reacting with what? Like you said, they both belong on the left-hand side. So when something is produced, where does that go in your reaction? goes on the right side, okay? Or results in the production of water and carbon dioxide. And it doesn't matter which order you put them in. Okay, I just have water and carbon dioxide up there. Okay. So with these, do you want to deal with moles or masses? Okay. So how many grams of acetylene do we have?
182.6.
Okay. How many grams of oxygen do we have?
37.
Okay. So with that context, okay, we want you to calculate the limiting reactant, because I think that's probably one of the toughest aspects to possibly deal with. So we see a measurement in grams. You're going to do what? Change it to moles. That's right. Okay. So, okay, we can balance it. Okay. Now, this isn't your typical hydrocarbon where you have odds and evens, because this is an alkyne rather than an alkane. But, so, if we have 2 carbons over here, what should we try on that side? Okay, so let's see once where that takes us. Let's look at our hydrogens now. Those are balanced. Okay. So it looks to me, yes, I would agree. That doesn't work. Okay. So when we did with alkanes, if that number was even, we would double it. So let's try that. Okay. So let's look at our carbons now. Okay. And then what does that do to our hydrogens over here? Okay. So we need to put a 2 over here. Now we're on the home stretch. 2 times 1 is 2. 4 times 2 is 8. That gives us 10. So we got 5 there. Okay. So let's go ahead and convert them to moles now. So how are we going to do that? 182.60 grams of, I'll just put AC here for acetylene since we know what that is. Next. Okay. Guess that's must be a cool reaction. We're talking about air conditioning, right? Yep. Yeah. All right. So that gives us 1 what up here? Okay. Now, down here. Okay. 6.04 is a little more than that. 26. Okay. Sounds a little better. Okay. And then you laugh, but this is human nature. Somebody might do that. Does a 2 belong there?
No.
Got a 2 here, though.
I think that only belong there.
Yeah, but we don't have moles over moles. You laugh, but it's well, I don't know if you're laughing or not, but people do possibly make that mistake. So if we were going to, let's say, calculate how many grams of oxygen there are, what would that next step be? Yeah, now you do your mole to mole and then another mass. But that's not what it's asking for. So that gives us an answer in moles, and that is, so 182.60 divided by 26.04. Agreed? Okay. So then let's go ahead and do The oxygen now. Again, some people, you laugh. If we're not careful here, we're going to do that. And that's wrong. Okay? But if you carry that with you all the time, that is diatomic, you won't make that mistake. Well, I mean, you might make it, but hopefully we learn from that. So this gives us 37 divided by, gives us 1.12. Holy cow, it looks like oxygen's our limiting reactant.
Nope.
Maybe. But we can't make that determination yet. The next thing we have to do is what? Okay. So which one you want to do first, or does it not matter? Okay. So, and then in this case, for every mole of acetylene, we want to change that to moles of what? Okay. Moles of water. Right?
No. Moles of oxygen.
Moles of oxygen. Agreed. Okay. Now we got a mole over a mole, so what does that tell you to do?
Coefficients.
Okay, so we got a 5 and then 2. All right, so let's see here. So 7.01 times 5 divided by 2, 17.53. Is anyone confused with where we're at right now? Do we know where we're at? We're in school, silly. Isn't that where we're at?
Yeah.
Specifically science, I suppose. Isn't an SDSU commercial where they give the latitude and longitude in one of them commercials? I think they do. So great things are happening up there. So the next best thing you can do for yourself is write what above there. Okay? And you didn't tell me we skipped something here. We could have wrote something here. What we had, right? Okay. Well, we need 17.53 moles of O2. Well, how many do we actually have?
1.13.
We're a little short, right? Okay. So that doesn't necessarily mean that's our limiting reactant yet, because it might be the one that runs out first. But I think with those numbers the way they are, that's probably not the case. See, we knew where we're at because they knew how to come and get back to class.
It's nicer outside than it is in your room.
Well, I've heard that before too.
It actually is.
Okay.
It's cold here.
What?
Well, that's because
Don't talk to me.
science is cool. I mean, how many times have we got to say that? Okay.
I kind of wish it was warm.
All right. Because we were talking about, do we know where we're at? I said, well, we're in school, silly. Okay. So now, do I really need to be recording this anymore? I think we're all. Oh,
See you next time.
your classmate. Oh, well, yeah, we're not quite that far yet. Your classmate to your right and your left.
Yep.
We're doing that for them.
That one. Yep.
Will
He'll
Will-
watch it.
he will?
Yeah.
Okay. So how are we going to do this step now? Okay. So moles of oxygen on the bottom, moles of what on top then? Okay. So we got our mole to mole ratio, which means we have to go back to here. And 5 and 2, where do they go? Okay. So 2 on top, 5 on the bottom. Okay. So 1.12 times 2, divide that by 5, 0.49. So with that analogy, is it pretty clear and concise which one is your limiting reactant? Yes, it is. And definitely, oxygen is your limiting reactant. Okay? Because we had $1.12. It costs $17.53, $17.53, if that makes it easier for you to make that analogy. Or you can say we've got $7 of acetylene and it costs 50 cents. Too bad we can't pay 50 cents for, because this is a gas, but you know, it's not the type of gas that your vehicle runs on. But was it yourself that said you had propane trucks? Trucks that run on propane? No? Okay. Oh, no. He was a senior last year.
Who's that?
I think it was
Right.
Lane, now that I think about it. Yeah, I have to ask Levi that, the other Levi. Said, yeah, we got trucks that run on propane. Yeah. It was confusing because that's where he sat last year, in $100 seats. Yeah. I mean, you sit further back, they're in the cheap seats. What do they know, right? Yeah. Okay, so left side. We're good? Okay, middle. Right side. Okay. What else could you ask about this problem? It could be the percent yield, but when you do that, you're actually calculating the theoretical yield. So pick one of these two. Okay. So how many grams of H2O are actually given off?
576.
Oh, I think that's a little, maybe.
Beyond or 100%. Oh, never mind.
No,
I'll put it like 37.
So regardless, we've associated our limiting reactant, we said, is definitely this. So label your limiting reactant. It's definitely the oxygen. Okay. So by doing this in our head, which I don't suggest that you do, so in that step, we're going to, so 37 times 18, then divide that by, we got to take it times 5 yet, don't we?
37 times 32.
Then divide that by 64. Okay, so let's, again, I'm just looking at this, trying to do this in my head as we go. So we'll see once where this takes us, that we're going to go 45 grams. Okay? 45 grams was collected. So if that was collected, that is an actual yield. That's something that you were actually able to grab. So on pencil and paper, you calculate your theoretical yield. We don't totally have to start over because we've labeled our limiting reactant correctly. And we don't use with what we have, or excuse me, what is required. We want to utilize what we actually have. So you could actually start here if you wanted to, or erase that and go all the way back to here. Does that make sense? When you do that, do you just start over, or do you go with the moles of what you actually had? Which is easier for you to understand?
I got grams.
Okay. Okay. So then, if that's the case, we would erase this. Okay. So then, with our limiting reactant, put moles of O2 here, and then moles of what? How do we get over to that side of the equation now? Okay. We've got a mole ratio. We've got a mole ratio.
5 on bottom, 2.
Okay. You know what? I flip-flopped those two. I divided by 64. I took that 2 times, so we're going to be way off on this. Okay. So then, with that, we're in moles of water now. How do we get to grams? Okay. For every mole of H2O, you get 18.02 grams of H2O. Okay? So, wow, I bet that's going to be a really, really small number. Okay? That's not very good. So, now, if we collected 5 grams, you said this was 8 point. Okay? So 5 divided by 8, that gives you your percent yield. Okay? Which I hopefully get better than that tomorrow. It's passing. Yeah. Okay. Is there anything else? I mean, there's just places that you can make mistakes, the mole ratio, setting up the problem. Don't forget, gases and halogens are what? They're diatomic. That's easy to forget that. Okay? Anything else? Like we really need those. Yes? Oh. I did. Oh. Yeah. Oh, I didn't have to give it to irresponsible younger classmen, did I? Right? Irresponsible underclassmen then? Yeah, probably not. Are you two done? No! You! Well, it couldn't have been that important. So what are we going to do next? It couldn't have been that cool then. Okay, I don't care either. You have no idea what they asked, do you? We don't want bonus points.
I'd rather have bonus points, yeah.
Oh, so now you want them.
Yeah.
Oh,
Never did want them.
sure. You could have fooled me. Well, obviously you did.
Obviously I did want them, yes. Who won't want them? You gotta be pretty stupid.
Well, that's what we were talking about while you two ding-dongs were looking at something else.
Guys, show me his new grill guard. He's been so bad.
All right.
Fall over here.
I'll never forget when I watched Breaker hit that deer.
What was it with it? What did he hit it with?
That green fish.
So I believe in the maybe starting in the 1950s, that would be really, really late. So I think it's in the 1960s and into the 70s, John Deere model numbers. Now we're not talking about toy tractors, we're talking about the actual types. Those on their model numbers ended in what number? Okay? You got 9 choices. No, 10 choices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 0. Yeah, so you got 10 choices. Yeah. Right?
You bet. Anyone locked in for tonight? Is it? Hello. Make sure you're locked in. It's all mental. You know that, right? Goaded. Good word.
No, it's bigger.
Wow.
Tell me to lose weight.
What were you saying? That's good.
I gotta make sure I spell. Well, help me out. Burt Reynolds. Burt Ren. Is it YLDS?
Like Reynolds?
Reynolds.
R-E-Y-N-O.
Is it? Okay. I know there's a Y in there. Okay. 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 So I don't know. I think there was 2 or 3 of those movies, and it was black in color. So
Dive? Dive. What part of the dive?
oh, all right.
That's alright. Everybody makes mistakes.
The black
Mhm.
dive.
See if you're paying attention.
Yeah, that's right. Okay. All right. So that's all I have. Exams next couple of days. Catch up to you next time.